Hi, everybody. This is front-end architecture for scalable design systems. For anyone who wants to follow along, I have a bit.ly URL to download the slides. And for anyone who has questions after this session, please follow me on Twitter. Ask me any questions, any thoughts today or in the future. I'd love to chat with you. So today we're going to talk about how to build a design system that is really for the modern era. One that has more maintainable code and documentation, make it easier for front-end developers and front-end architects like myself to be able to keep things up to date. One that's flexible. We should have our systems be set up in a way to allow developers to be able to choose the kinds of components that they want to pull in and update. Our system should be able to be integrated easily. For example, you should be able to have a design system that has Twig templates that Drupal, Symfony, Pattern Lab, any other platform that supports Twig should be able to integrate it with it seamlessly. It should also be framework agnostic as much as possible. You should have a system that works with JavaScript frameworks like Angular, Vue, React, etc. It's a lot to cover. We have 45 minutes. Let's get started. Dziękuję, Wrocław. You have a very beautiful country. It's my first time in Poland. Thank you so much for having me here. My name is Salem Ghoweri. I'm lead front-end architect at Pegasystems in Cambridge, Massachusetts, in the United States. I've been a front-end developer for the past 7 years, and for the past 4, I've been focusing almost exclusively on design systems and pattern libraries. I'm also the creator of the Bolt design system that we'll be chatting about today, and I'm a core contributor on the Pattern Lab project. It's an open source prototyping tool for front-end developers, designers, really anybody, both the PHP and the Node.js versions of Pattern Lab. We'll be chatting more about that in just a little bit. But first, we need to go back in time. About 3 years when I first started working at Pega. Back then, the front-end code in our sites for Drupal wasn't that great. So we used the best techniques, the best practices at the time, bleeding edge as far as Pattern Lab and Drupal goes, and we built our first design system. Our front-end code base was really great. We used all of the best practices and techniques, atomic design, Sass, Webpack, Twig, BEM, CSS, inverted triangle CSS for a great CSS architecture, and things were really good. We also followed many of the best practices for a best-of-class Pattern Lab Drupal integrated website, design system, style guide, whatever you would like to call it. We did what all the blog posts and all of the DrupalCon presentations talked about. We built our components in Twig. They lived in Pattern Lab. Drupal pulled those components in using the Twig namespaces from the Drupal components module. We documented our components via demos and examples in Pattern Lab for other developers, content authors, and designers to reference. And we did the very we did the very modern technique of actually having our design system code base split up into a separate Git repository that got pulled into Drupal to make things more maintainable and more customizable. So many of our Drupal sites used this first design system. And things were pretty good until they weren't. Unfortunately, our first design system started having some problems, some major scalability problems. We had poor documentation. We had questions being asked like, how come these component documentation items are out of date? Or what data does this particular thing require? We had issues with shipping our code and distributing it. We had teams asking, I only need to pull in this one component. Why do I have to pull in all these other updates? Or why am I having to install Pattern Lab along with the components that I want? We also had issues with fragmentation. Once components were published, we found that content authors were still hard-coding components on the page that we had no idea about. We had issues keeping the code that we'd already shipped in sync with the latest version that we were expecting. So we had bugs, we had issues. And the integrations themselves, they were actually quite fragile. The static Twig namespace approach, the best practice at the time, is very brittle. You change one folder name inside of your code base, and everything breaks, and you have no idea about it. The fragmentation issue we were dealing with, in fact, got so bad that one of our Drupal sites asked us, we need half of the design system code to work on half the site, the new version, but the other half has to be locked to the version you released a year ago. Completely split down the middle. And by that point, we knew our first design system was dead. So we picked up the pieces and we rebuilt. Now, a scalable design system, who here knows what a design system is? So a design system, it's like a pattern library, it's like a living style guide, but it's the next evolution of that. A design system really is the front-end components, the UI patterns, the best practices, accessibility. It's the code, the design, the color palette, the typography. It's all of those things that make up the front end for your website, or, for most cases for design systems, multiple websites, and ships it in a way that you can have consistency across your organization. First there were living style guides, then there were pattern libraries, now we have design systems. A scalable design system, really, which is what we were trying to do, needs to solve two main problems. Maintainability, you need to figure out how you maintain, support, and improve your design system over time. That's things like bug fixes, having documentation, testing coverage, etc. You also have to deal with the fragmentation issue, the thing that really killed us with our first design system. You need to make sure that once you've shipped code out into production, you have a way to keep it up to date and in sync and prevent things from falling apart. Without these two things, you can't have a scalable design system. So we created Bolt. The Bolt design system, it's been around for about 2 years now. It's open source, it's on GitHub. It's great. This is our solution. It's not a product, by the way. It's really just our front-end solution for the scalable design system architecture problem that historically tools like Pattern Lab just haven't quite been able to solve for. It was one-time only site installs, not something you can maintain over time. So for Bolt, the Bolt design system, we had 4 main goals that we came up with. Documentation and demos need to be easily maintainable, and it has to be easy to keep things up to date. We need to make sure that the components we're creating are flexible for developers and content authors, but they're also rugged and encapsulated to make it easy to share the work that we're producing across multiple websites in multiple use cases. The design system also needs to be installable piece by piece, which all the previous solutions we've seen, all of the best practices and examples we would have referenced, all of those systems have the design system installed as one gigantic thing, not as things you could pick and choose. You want just the button or just the card, but you don't want the grid? You can't do that with these old systems. We wanted to make sure this new design system we were creating solved that problem. And finally, integrations. They need to be as automated and as painless as possible for developers. We want this thing to be wired up and stay up to date and not have something silly like a template folder getting renamed internally end up breaking everything when you try to pull it into Drupal. So how do we do that? Well, first, we had to find a way to make our documentation easily upgradable, easily maintainable. And we do that through APIs. So step one, write good code. Code needs to be written in such a way that it's structured. It has to have, so this is anyone who's written Sass before. These are Sass maps. So all of the colors for our brand are all organized in one single area. You don't have one file has one variable here, another file has one variable there. So reorganizing our code to use Sass maps was step one. Step two, share that data. So having your design system's colors in one file is great, but you need to be able to export that data in a format for step three, so that we can teach other systems about that. So we have our Sass with our colors. It exports it out into a JSON file. Could be YAML, could be anything else, but for us, JSON made the most sense. Step three, we need to be able to teach other systems like Twig about the data that we have in our system, so that step four, we can use it. This lets us create documentation, say, on our color palette, so that if we change our color palette data, change the options from design, this stays always up to date. It's maintainable because there's no work. It also lets us do really neat things like this. This is accessibility check. Goes through every color palette option that we have and sees if there's enough contrast on light text and dark text, on large text and small text. Automatically, no one has to ever change this, it just works. Next up, component schemas. So what is a schema? A schema is essentially the API for your components being described in a way that is easily read by humans and computers. Schemas let us define the data for structured data for our components to allow for, say, automatically checking things for regressions, or validating and enforcing the data passed along to our components to ensure that the data we're passing along is most up to date and it's being maintained, it's being tested against. Which really this lets us make changes to the design system's API so that over time things don't break, they stay up to date, they're using the latest specification that we've defined. So how do you do this? Well, for starters, write schemas. Step one, this is an example of our button component. We just define the data for the button. So for this example, we might have text. So the button can take text. The text should be a string. Therefore, and it's required. So if we don't pass along text data, we should know about it. The next step was actually from experience doing this for many of our components. We found that it was actually more helpful to pull all of that data together into one place first, considering many of these systems could have 20, 30, 40 plus components. Putting all of the data in one spot made it a lot easier for performance and also for checking that data is correct before step three, teaching other systems about the data. You see a pattern coming. Define the data, clean it up, and then teach other systems how to use that data. So this is just an example in one of our Twig extensions of teaching Twig how do you validate schemas. So based on the data being passed along to the component and based upon the rules that we've defined in our schema file, see if the data is valid or if there's an error. It also works for other systems like JavaScript. So same idea, just different language, but exact same file, two different templating languages to still enforce it, validate it, and and help keep the data up to date and correct. And then you use it. So this is an example of the button component pulling in the button component schema. It's looking at the different button sizes that we have and automatically generating every size example in our documentation. We add a new size button, this is already up to date. No one has to worry about updating that. It also lets us do things like this. This is a table displaying all of the API or configuration options for our button. You add a new option to the schema, this is already up to date. You don't have to update the documentation site. It just works. We can also do some really interesting things like this. This is one of our Jest tests. Anyone here know Jest? So Jest, for those that you don't know about Jest, it's a way to write tests for JavaScript components normally, like React. But we actually found that we could use the same tooling, the really powerful tooling, and pull in the schema and have our Twig templates that are getting rendered get checked in the same exact type of testing framework. We're basically using the best tools we can find to solve the same problems that other people have to deal with. We can also use it for really neat things like this. This is schema validation that shows up in our terminal, in our console. Whenever you pass along incorrect data, like in this example, we are calling our button.twig file. We're saying I want an icon, that's the close icon, but no text, which is required. It throws an error, unable to compile. We can also expose that same data in the browser's console. This is actually right inside of one of our Drupal examples, schema validation that's outputting a JavaScript error because certain templates on this page didn't get the data they expected. We can also do some really neat things like this. This is our component explorer that we're slowly adding to each of our examples. This essentially is a playground for seeing all of the available options for your component. You change the option. It makes a request to a Twig rendering service in the background, takes the new data, and then outputs the HTML straight from Twig. It's really fun to play with. You could really think of schemas as the one thing to rule all component validation and maintainability. It checks for validation in your command line and in the browser. It lets you write easily maintained tests. It defines the configuration and the configuration defaults automatically, so people using your templates have to put in less options that are actually needed. It lets you generate documentation that's up to date automatically, and then it makes it more easily, you can generate demos for your system more easily, and also do really cool things like the Component Explorer. Next up, let's talk about Twig and web components. Who here has heard about web components? Definitely Google it, look it up. It is so incredibly cool. I am such a huge nerd for web components. The more I use them, the more excited I get. Web components are a way to build modern, first-class components in the browser that work everywhere. Technically, they're actually a really low-level browser specification of custom elements. It lets you have custom HTML tags, like in our example here, bolt-button or bolt-icon. It's a custom tag that tells the browser, this is a new element, it's different, here's the behavior, here are the options. It lets you do things like Shadow DOM, which packages up the component's HTML and the CSS. So if you installed a component and put the right, say, JavaScript tag on the page, all of the markup that's needed for that component is basically separated from the markup that you see on the page. It's kind of hidden away, which makes our components much more encapsulated and stable. HTML templates are also part of the technical specification for web components. Now, these let us stamp out really simple templates to optimize how the component actually generates its HTML. We don't use HTML templates too much, but they are part of the specification. And then we have imports, ES imports specifically. And this is really just a way to allow JavaScript files to pull in other components as a dependency. That's the low-level stuff. The great thing about working with web components is so many frameworks and libraries actually support web components out of the box. There are tools like lit-HTML and lit-element, both from Google, that work with web components natively. The Ionic framework with Angular, I believe Ionic 4, was released very recently. That supports web components right out of the box and has this great tool, Stencil.js, to make it very easy to generate these web components. And then there are other tools like Skate.js, where if you can't find something that meets your needs, you can actually generate your own framework or library integration. Just adds a little more simplicity to working with the specifications. It also works with almost every other JavaScript framework that's out there right now. React, Angular, Vue.js, really almost every major framework out there supports either 90% of web components, if not 100% of web components. And if you're wondering, well, what's the cross-browser support like? At this point, it's actually really good. Chrome, Safari, Opera, Firefox, they all 100% support the web component specification. Edge, the new Edge will actually fully support everything. Older Edge has partial support. And if you're like us and you have to still support IE11, there are polyfills that make all of these great features of encapsulation and automatically responding to data changes, etc., make support available to everybody. Really, you could think about it as this technique that we're doing is a way to have your Twig templating, your JavaScript templating work everywhere. In Twig, in JavaScript, in plain HTML, there's one component. There are also really powerful things you can do, like having Twig, our Twig templates that Drupal pulls in, be able to pre-render our web components so that if you didn't have JavaScript turned on, or if it's slow to download, or there's an error, not in your code, but in someone else's code, you can actually have this method generate the HTML that you'd expect from Twig, generates the HTML that the web component needs. If the JavaScript broke then and there, you have a simple version of that component, still styled. And then once the JavaScript boots up, the replace with children, this one right here, that gets rid of extra HTML on the page that once the JavaScript turns on, gets rid of that so that all the HTML that's left is what the web component expects. Just very simple bolt-button with a URL generates everything that you need. Now, Shadow DOM. Shadow DOM is one of the most powerful features of web components. It lets you essentially, from the outside, on the left here, this is all that you would see from the outside, just the simple bolt-button tag. But all of the HTML that's below it is what internally is getting generated to put your text, your icon, etc., to really structure that. But if your browser doesn't support Shadow DOM, or for our case, after doing testing, we found Shadow DOM is fantastic, but it's very heavy to get it to work back in IE11. So we actually decided if you're an older browser that doesn't natively support it, you don't get the extra polyfill to make things faster. We actually make sure every one of our components can render with or without Shadow DOM. So rather than the top left corner, you basically just get your regular component rendering with JavaScript right there. It also works with, like I mentioned, almost every JavaScript framework out there right now. So this is an example integration of Vue.js. You can check it out on the GitHub URL there. We also have one demonstrating the same approach in Angular and static HTML. So not even if you don't even have a JavaScript framework, if you just had a plain website getting generated by this framework, this backend system, absolute worst case, if you didn't support Twig, you could still use this approach of having one component, the data that you could pass along to the component, the rendering and responding to changes and events, all of that packaged up in a way that works everywhere. This is why I'm so excited about web components. Next, let's talk about decoupling and how we threw out the book, the rule book, on how we've distributed our design system. And to do that, we have to talk about monorepos. A monorepo is really a repository, a code base, that has all of the pieces to your project or your library. These pieces can be all related, so your components, your grid, your colors, but they can also be unrelated. They could be things like tooling and shared configuration. Many of the most popular JavaScript frameworks out there, things like Babel, Gatsby, Webpack, they actually are using monorepos. They've been using monorepos for some time. But, and this is to my surprise, many of the most popular PHP frameworks out there, like Symfony and Laravel, their code bases are done the same way too. So why? Why monorepos? Well, for starters, it provides us with a more maintainable code base. For developers, this makes it easier to share and reuse code across your design system, across your components. It makes it easier to know when you make one change to, say, the icon, these other components that use icon might have to get a similar update all at the same time. It significantly simplifies how we build, test, deploy, document, everything. We can unify the entire process to make it much easier and quicker to release updates. It's also really a place for people to report issues, bugs, and put any notes about your more recent releases. It lets you test related components together. You don't have to go to the button Git repository to test the button, and then the icon Git repository to check the icon. It's building your design system as a monorepo means all the pieces are there, and you can check all the pieces all together, and in separation. And like I've mentioned, really there's only one source of truth to make any changes over time, to update your code, update your demos, update your documentation. Just one repository for your entire system as a contributor. The other, if you remember, one of the big goals that we had to figure out with our system, we also needed a way to let people pulling in our design systems code base. In Drupal, how do we allow developers to just pick and choose the parts that they want? So they only want the button, they only want the card, etc. But from the people contributing to the design system's point of view, there's one code base. You get the best of both worlds. So this was really just showing how, from my point of view, there's just one code base with all of the different pieces. We publish these to NPM, Node Package Manager, which is easily the most popular place to put any front-end code on the internet right now. And then from the outside point of view, you only install the parts that you need. We use a tool called Lerna. It's been around for several years now. It's fantastic. And Yarn. Yarn is, if anyone's not familiar with Yarn, it's basically, it does the same thing that NPM does. It makes it easy to install the different things you want from a registry like NPM. Combining those two has made building and publishing a monorepo extremely easy. We have a small config file, this lerna.json, that says use Yarn's own support for this technique. We have our package.json file in our repository in the root. It says I've got components in this packages folder, or maybe my documentation site is going to be referencing my components. And then once you have your code where you want it, learn a publish. It asks you, hey, here are the changes that you have. Is this what you want at this version? And then it publishes the changes to NPM for people to use. Worth mentioning, Pattern Lab and the design system are completely different things. And as a core contributor to Pattern Lab, this has taken me a while to really understand and really appreciate what this has allowed us to do with our system. Traditionally, Pattern Lab was where your components lived, all the code. With doing this for several years now and seeing what's working, what's not working, we've come to realize that reorganizing your components to live outside of Pattern Lab and the Twig, the Sass, the JavaScript, everything lives separately. They're just demoed in Pattern Lab. Pattern Lab actually is showing how any other system like Drupal would be installing and using those same exact components. It made Pattern Lab really just another integration, just like Drupal. We also learned that many of the best practices out there, many of the DrupalCon presentations from the past, or the blog posts, the examples of our style guide integrated, Pattern Lab style guide integrated with Drupal, or Pattern Lab pattern library integrated with Drupal, or nowadays Pattern Lab powered design system integrated with Drupal. Many of the best practices that are recommended, you shouldn't do. We found that using what can be taught to other languages, other systems, was the most stable and easiest to integrate approach. We still use Pattern Lab, but we only do things that Drupal or Twig itself can be taught. And that really lets us use the design system to power Pattern Lab. We have a static Twig static site generator, Drupal. Any of these other systems all integrate through Twig. That's the secret here. 2 more slides, and I think it's our last session. Reorganizing your code base. So the design system has the pieces that get shared to the world, your components, your configuration, your tooling. That all lives in one place. Separately is everything else. Examples showing how to actually use the design system, the documentation site that is demoing the design system. It's still the same code base, but there's one real folder with smaller subfolders that get published and shared, separated from all of the infrastructure that keeps the system's code base up to date and maintained. And in case you're curious about pure PHP dependencies, we realize that NPM is great for publishing front-end code, node code, back-end code to an extent, but for things that are pure PHP-based, we actually use the exact same technique that Symfony is using and have 2 specific folders that are pure PHP dependencies published to packages separately whenever we're doing a release. Composer require bulk connect or core PHP, and then npm install everything else. Last, let's talk about integrations. One of the largest, if not the largest goal for this whole design system reboot that we've been doing over the last several years now is this idea of a la carte. Pick and choose just the parts that you need. Let Drupal developers be the ones to decide, I'm ready to upgrade to this new version. Leave it up to the subject matter experts to decide, I'm going to install these pieces and the tooling, and maybe hold off pulling in this latest update. So really, it's just a 3-step process. Step 1, npm install what you want, and then we have, with how we're having the system set up, we have our build tools. We look at the components that you want to use, that you've installed, and we actually generate the Twig namespaces and teach Drupal about the Twig extensions that the system's using. Step 2, you configure the tools to know where your code base how it's organized in your folder. So, these is where I can serve my CSS or my JavaScript files. This is also really solving the big problem of I've installed the button, but maybe I need to turn it off for a little bit to work on something and then turn it back on. So this configuration allows us to install the components, step 1, enable or turn on the components, step 2, and then step 3, we have this Bolt Connect Drupal module, which automatically takes the data that the build generates of all the Twig paths, and it teaches Twig inside of Drupal, here's all the paths. Here's how to use the design system. So, just really quick to wrap this up, we have our package.json file with the files that we want to install. These go into our node modules folder. And it actually works with dependencies too. Button requires the icon. If you only install the button here, if you didn't already install icon, it'll pull it in and wire it up automatically. And then we list off in our Bolt RC config, these are the components that we want to use and turn on. And then in a normal Twig template, that's it. It just works. We actually have a fully working example of this in our Git repository on GitHub. We're using a super small version of Drupal called Drupal Lab, which makes it incredibly quick to get this all up and running. And if there's a minute or two after this, I could pull up a demo of that. So we've covered so much stuff in a very short amount of time. Let's go back through this very quickly. Component schemas, they're a very powerful way to describe the rules for your design system's components to allow for better testing, documentation, and consistency. Building our components to be Twig and web component based allows us to have more flexible, more sturdy, more future-proof components that work everywhere. Progressively decoupling the design system, saying, hey, Drupal is an integration, Pattern Lab is an integration, here's the pure components and the styles that we have, and everything else is an integration. This has allowed us to really build a more organized and better maintained design system that scales. Publishing the design system to NPM lets developers outside of your system pull in just the parts that they want and need and upgrade when they're ready. And finally, automating the Twig namespaces, really the master rule that Drupal needs to know here's the folder or the file for this template. Automating that process has allowed us to completely eliminate path changes breaking things in Drupal. Like I mentioned, take a look at our code, bolt-design-system/bolt on GitHub. Slides are posted with all these being links. And if you're curious to learn more, check us out on boltdesignsystem.com. And we're also, funny enough, on the Drupal Twig Slack channel on the Bolt Design System channel. I didn't create that. There was enough excited people, they want to learn more about Bolt. Dziękuję. Thank you. Questions?
Thanks for the presentation and all the details. I'm a little bit interested for how to make a test, because you mentioned it a little bit, especially for visual regression, if you have something.
That's been, so the last 4 months, I have been in almost pure testing, the world of testing. And what we're doing is we're actually taking our tests and dividing them into several different categories. Most of our tests are actually based on jest. So in our jest tests, and we have, I think, 200 tests at this point, and we started with maybe 15 or 20 in January of this year. So Jest does the Twig-generated HTML check. Jest can render, basically create a browser environment like that on the fly, create a web component, a JavaScript powered component, add it to the page, change the data, see how it renders. There's also some great plugins because we're reusing a tool from another community. We can actually run our visual regression tests right in Jest. And if the screenshot changes, because we've already done our Twig template rendering, our web component rendering, we can use that exact same test and also take a quick screenshot of what it looks like. And if it changes over time, stop it. Stop the build, put an alert. Jest only works with Chrome and Firefox right now. So we also use Nightwatch.js, which I believe is pretty common in the Drupal community, to supplement those tests with cross-browser tests, behavioral tests. Scroll to this page, click on this button, check to see that the video has started to play, etc. Our approach is to do multiple layers of testing to make things more stable and more predictable. It's not just one solution.
Just to add on that, I work with Salem and Pega. Every time we integrate both, we upgrade a version. We actually do visual regression testing of Drupal, the Drupal site integration key pages, using custom Java scripts like swinging scripts that take screenshots of those pages of the baseline, which is basically production, and the other baseline, which is the dev site. And we use a product called Tools, which does side-by-side comparisons across different browsers and different breakpoints. And that's been really helpful to find issues after the integration actually happens. Tools is a commercial product.
It definitely takes a team effort to have real good testing coverage and stability. Everybody has to pitch in, and it's made a huge difference. Any more questions?
Drupal provides any other integration than Drupal?
Twig integrations is what you're asking. So take a look at the Bolt design system Codebase. Right now we're demoing Drupal integration, a bunch of JavaScript framework integrations. The way we're integrating with Pattern Lab and also the in-browser component explorer, the playground, we're really just integrating with vanilla Symfony's Twig. So if you can figure out in, say, Grab CMS or Symfony, here's how to add the Bolt core Twig extension, that's all you need for integration. We really wanted the system to be as future-proof and as flexible as possible to provide our team with that flexibility in the future, but also hopefully help other teams that use different technologies or multiple technologies maybe get some benefit from this approach as well.
You mentioned progressive decoupling or
Mm-hmm.
progressive decoupling. I tried doing this and I found it challenging to do like JavaScript routing. I was using React and trying to use React Router. Did you use JavaScript routing in these projects or are you using Drupal?
Ask me at DrupalCon Amsterdam in October, fingers crossed. I might be able to get more into that, but right now we don't have any JavaScript routing. We're basically providing all of the Lego blocks, everything from the icons, buttons, cards, grids, whole sections of the page. But the routing, we're still deferring to Drupal to allow it to decide how to do the routing. So we still have all of the UI and that consistency, but we're compromising by letting the routing get handled by Drupal. We would like to get into more routing, JavaScript client-side routing solutions in the next couple months. I know it's challenging, but we're really excited to see what we can do. Any more questions? Well, if you do, again, check us out on GitHub, ask me on Twitter, and thank you very much.